towering 167 meters over Las Vegas. This is North America's largest observation wheel, the High Roller.
Because of building in Vegas, it requires you to build the biggest and the best.
Las Vegas's star attraction must keep turning and give the thousands of tourists who flock to this city the ride of their lives.
It's going to be a busy, busy night.
How did engineers build this mega wheel in the sky? And how does it deliver one of the most spectacular views in the world?
We wanted our guests to feel like they were floating in space.
We unlock the engineering secrets that help the High Roller wow the crowds. From its one-of-a-kind single rim to the ingenious capsules that stay perfectly level through every rotation, to reveal what it takes to build the ultimate mega wheel.
Welcome to Las Vegas!
With its bright lights, hotels and casinos, Sin City is famous the world over. 40 million tourists flock here every year to try their luck at the gambling tables, watch spectacular shows, and soak in the glitz and glamour. They spend close to $35 billion each year. Competition between hotel casinos vying to bag a bigger share of this revenue is fierce. They erect ever more spectacular attractions to draw in larger crowds. To stand out, Caesars Entertainment decided to build big. They constructed this. The Las Vegas High Roller. Costing $300 million, this megastructure now defines the Las Vegas skyline. It is built to a revolutionary design and requires a team of skilled mechanics to keep it moving. The wheel's objective is to reward intrepid passengers with unrivaled views of the city. The High Roller is built with innovative technology hidden under the hood to help wow the crowds and give them the ride of their lives. "28 temperature-controlled, precisely geared capsules stay perfectly level all the way around. A unique single-rim design provides near unobstructed 360-degree vistas across Las Vegas. And a mighty hydraulic arm comes to the rescue if the power goes out. All these elements combine to make the High Roller the ultimate observation wheel." General Manager Eric Eberhardt led the team tasked with making High Roller a reality.
Because of building in Vegas, it requires you to build the biggest and the best and offer something the guests cannot experience anywhere else in the world. We really push our designers and engineers to create a world-class attraction that's unique and push the boundaries of observation wheels.
And this weekend promises to test this revolutionary wheel to the limit of its endurance. It's spring break. An estimated 800,000 people will descend on Vegas looking for a good time. The wheel must complete 130 rotations, each taking 30 minutes, and carry thousands of people over the next 4 days, stopping for just 6 hours each night for critical maintenance. Breakdowns will dent Caesar's reputation, and potentially drive away visitors eager to spend their dollars at the casino's gambling tables. The pressure is on. Thursday, 8 p.m. The long spring break weekend rush begins. High Roller's entrance hall fills with tourists eager to glimpse the wonder of Las Vegas at night.
I'm really super excited to see the hotels, the beauty of them, and all the lights of Vegas.
The first challenge for building a wheel this big: how to keep the 160-meter diameter frame rigid. Its narrow single rim doesn't look tough enough to support its 1,800-ton weight. High Roller's strength is the result of a groundbreaking innovation built into its DNA. 1893. Engineer George Ferris unveils the world's first great wheel at the Chicago World's Fair. To keep the wheel strong but lean, Ferris pioneers a spoke design that becomes the blueprint for almost all later wheels, including the High Roller. The cables hold up the bottom half of the rim. Their tension pulls the rim inwards. This allows the top half to support itself like the arch of a bridge. These two forces work together to keep the entire rim strong and rigid as the wheel rotates. But erecting a structure this tall and thin is a unique construction challenge. If engineers build High Roller from the bottom up, the cables support half the wheel's structure. But building the top half unsupported will overstress the rim and trigger a structural collapse. One solution is to support the wheel with a scaffold 167 meters tall. But scaffolding this high is unstable. Its footprint must cover a huge area to stop it from falling over. But this sprawl will encroach on neighboring roads and buildings. How do you build North America's tallest wheel without building the continent's largest scaffold? In the late 1990s, the engineers building the 135-meter tall London Eye used geography to solve the problem: the River Thames. They assembled the wheel horizontally on platforms in the river. Once the rim and spokes are complete, they lift the entire wheel into its vertical position. In Vegas, building High Roller horizontally is impossible. The city has no river. Giant hotels and transport infrastructure surround the chosen construction site. Project manager Randy Prince must find the solution.
Logistically, this was a very challenging project. We've got two major hotels that had to remain in operation. We had to keep a roadway in operation because it was an emergency fire access throughout this entire project.
Randy's only option is to build High Roller vertically, but with one critical modification. His team deploys an ingenious solution to stop the wheel from collapsing under its own weight as they build upwards. First, they fix a pair of 68-meter long metal struts to the wheel's central spindle. To this, they attach the first 16-meter long section of the rim and cable spokes. Next, powerful hydraulic jacks push this completed segment around by 13 degrees. Engineers then repeat the process, joining together more struts, rim sections, and cables. The rotating wheel stays rigid and stable as it grows segment by segment. Once all 28 rim sections are in place, engineers fit and tension the last of the wheel's 112 steel cables. They remove the struts one by one until the wheel supports its own weight on the central spindle.
When that last strut came out, I think it validated for all of us the designer's vision. There you had this purely circular form redefining the Vegas skyline. And we went, wow.
Today, the High Roller is a Las Vegas landmark, visible from anywhere in the city. On the first night of spring break, the High Roller carries thousands of people visiting Sin City for the long weekend. But a new day brings new challenges the super wheel must face. How does this monster machine beat damaging desert winds? And what is the engineering secret that gives the wheel spectacular, near unobstructed views? Friday morning in Las Vegas, the second day of the long spring break weekend. The High Roller spins over 1 million tourists each year, but passenger numbers surge during busy holidays. Everybody stepping aboard is a potential customer for Caesars Palace Hotel and Casino. The wheel must deliver the ride of their lives. These passengers are the latest in a long line of thrill seekers, eager to fly on ever larger mega wheels. In 1893, George Ferris's revolutionary 80-meter design triggers a race to build bigger. Over the next 100 years, observation wheels grow steadily larger. But it's not until the 21st century that they get really big. The 135-meter London Eye becomes the world's tallest wheel in the year 2000. 6 years later, this 160-meter wheel, called the Star of Nanchang, steals the crown, only to be beaten by 5 meters by this wheel, the Singapore Flyer, in 2008. The High Roller adds a further 3 meters to the world record, and it could have been even bigger.
We always wanted to make the High Roller the biggest and the best in the world. We were somewhat limited. The major international airport, McCarran, is less than 5 miles from here, so the Federal Aviation Administration limited the height that we could go to, so we took it right to the limit of 550 feet.
Size is just one objective for High Roller's designers. The bigger prize is to write engineering history. Build the first wheel in the world with near unobstructed 360-degree views from every capsule, at every point of rotation. All big observation wheels, from Ferris's original to the Singapore Flyer, are actually 2 wheels bolted together. 8-meter wide trusses join the 2 rims of the London Eye. This means for most of the rotation, the wheel's physical structure blocks passengers' sightlines from one side of the capsule. Only when a capsule reaches the very top do those inside enjoy an uninterrupted vista. To realize the dream of near unobstructed views, High Roller's engineers simply remove one entire rim and all the trusses.
So this is what the High Roller is all about. We eliminated most of the visual obtrusions and really give you the sensation of floating. And it gives you a full 360-degree view.
The effect is a big hit with Vegas's spring break vacationers. But building an observation wheel with just one rim potentially leaves it vulnerable to the forces of nature. The traditional two-rim design of wheels, like the London Eye, makes their structure stiff. It's this stiffness that keeps these wheels rigid in strong winds. Removing one rim reduces rigidity. In strong winds, there's a big risk a single rim design could flex. The bending wheel could hit critical infrastructure and overstress its cables to the point where they snap and risk a catastrophic collapse. Las Vegas sits in a valley in the Mojave Desert. This geography leaves the city vulnerable to strong winds. High Roller's team monitors the speed of the wind from this dedicated control room.
Good. Can you pull up the weather so we can check it real quickly, please?
Sure.
Low wind speeds today, that's good. The days preceding this weekend, we had quite high wind gusts coming through the Las Vegas Valley. Some gusts were as high as 60 miles an hour.
In theory, winds this fast could fracture a single rim wheel and shatter the dream of engineering the illusion of floating on air. So to eliminate the natural flex in a single rim design, High Roller's engineers devise an ingenious solution. They extend the length of the central spindle to 30 meters, nearly 4 times the length of the spindle on the London Eye. This widens the angle from which the cables pull on the rim from either side, just like the guy ropes on a triangular tent. The longer central spindle makes the High Roller as rigid in strong winds as a traditional double rim wheel design. The wheel stands firm in strong winds, but gusts still have the potential to ruin the experience for the thousands of tourists riding High Roller this holiday weekend. Wind vibrates the tubular legs that support modern observation wheels. This movement can rock the rim, wobble the capsules, and make passengers nervous and seasick. Hidden inside the support legs is High Roller's secret for beating the shake and to guarantee a smooth ride every time.
Any sudden movement is going to detract from this experience of basically serenely floating in the air as you go around and look at Las Vegas. We needed to do whatever we could to make that experience as smooth as possible.
Engineers fit special devices called tuned mass dampeners to combat vibrations. Each of the 13 dampeners consists of a weight of up to 60 kilograms, suspended by cables, attached to tuned springs. Together, they counteract vibrations caused by wind to give passengers the sensation of floating on air. By 2 p.m. Friday, this windproof wheel has spun hundreds more spring break tourists high above Vegas and the Mojave Desert.
It's amazing. I mean, I did get the butterflies in the stomach a little bit, but it was definitely a nice experience.
I've gambled and lost a lot of money. You go, you enjoy some good food, but this is totally different than anything that I've done in Vegas.
As the sun sets on Sin City, Friday night promises to bring even larger crowds. How did engineers build this huge structure to fit in the middle of crowded real estate? And what is the secret for turning a 2,200-ton mega wheel? (8 p.m. Friday in Las Vegas. Tonight, High Roller must spin close to full capacity, carrying over 1,000 passengers every 30-minute rotation. It must keep turning to draw the crowds and drive business to Caesars Restaurants and Casino on one of the busiest weekends of the year. As darkness descends, Las Vegas lights up, and so does this city's big wheel. "2,000 LEDs cover High Roller in a chameleon cloak of light, turning the wheel into a beacon visible from anywhere in the city."
Obviously, Las Vegas is the city of lights, and there was no doubt that we had to put on a very special show when we opened up the High Roller. These two panels allow us to select from a color wheel of colors and allow us to set up the wheel for special events or just our normal operations.
High Roller also offers a special service to attract the spring break party crowd.
Yeah, we are officially at the time to meet the shot time!
For a fee, visitors ride with a personal bartender and fully stocked bar.
Vodka soda, fresh glass. There you go, cheers.
At the halfway point in the spring break long weekend, this 167-meter tall wheel has completed 72 rotations and carried thousands of tourists. A wheel this high must stay perfectly vertical at all times to run smoothly. High Roller must have a rock-solid foundation, or there's a risk the mighty metal ring could topple over. Traditional wheels stand on A-frame structures angled outwards. They guarantee stability by spreading the wheel's weight over a bigger area and lowering the structure's center of gravity. But to build wide legs, you need space. And that's in short supply in this part of Vegas. High Roller's construction site is located in the middle of prime real estate. It sits in an area crammed with obstructions. A 19,000 square meter retail development. The intersection of two busy roads. And a section of Las Vegas's raised monorail. These obstacles restrict High Roller's engineers to a construction footprint of only 65 meters by 22 meters. The problem is, no matter how they orientate the High Roller, the giant wheel cannot fit on the site without hitting a building or standing in the middle of the road. Borrowing from previous designs is not an option. Other 21st century wheels like the London Eye and Singapore Flyer stand in less cluttered areas with space to stretch their legs. Engineers must devise a unique solution to fit High Roller inside its tiny footprint. They turn the wheel's legs to angle inward, so they touch the ground within a narrow 1,430 square meter area. The wheel is solid along its north-south axis, but its narrow stance makes it unstable along its east-west axis. Engineers build an ingenious fifth leg out from the central spindle to secure the wheel. It reaches over the neighboring road, and touches down in a nearby car park. 5 points of contact with the ground gives High Roller perfect balance. Once workers complete its foundations in mid-2012, it takes another 2 years to finish the wheel's mighty structure.
In order to complete the High Roller on time and on budget, it had to be a very well choreographed operation.
We literally had parts and pieces coming from all over the world. Steel from China, glass from the cabins from Italy. We had to coordinate an enormous amount of material coming into this site, getting brought in just at the right time.
It takes 7,700 meters of cables, over 2,000 tons of steel tubes, 28 capsules, each weighing over 27 tons, and a workforce of 600 to construct the ultimate observation wheel.
Building anything on this scale is quite an endeavor and quite challenging, but it is also extremely rewarding.
When we finally get open, and you see thousands of people streaming by going ooh and ah, looking at the wheel saying what a wonderful thing it is, and you get the chance to say, you know, I was part of that, you go, wow, that was a pretty special thing.
By the end of Friday night, the super stable High Roller has spun thousands more spring break vacationers. But tomorrow promises to be the busiest day of the long weekend. What innovation will drive the 2,200-ton wheel non-stop for 16 hours? And what's the secret to keeping High Roller turning even when the power goes out? In Las Vegas, the High Roller has spun thousands of people over the first 48 hours of the spring break holiday. Passenger numbers can double at weekends, and this Saturday evening promises to be even busier. It falls to Operations Director Carolyn Gargiulo to ensure the wheel's ready to meet the demand.
It is a Saturday night, which is typically extremely busy for the High Roller, and we have a private event on top of that, and then of course our general admission guests. It's going to be a busy, busy night. We will be stressed to our max and pushed to our limits.
Tonight, High Roller must spin close to 1,100 people every half-hour rotation. Driving the vertically mounted 2,200-ton mega wheel around and around non-stop is a huge engineering challenge. The center of the wheel is the obvious position for a motor, but rotating High Roller from its spindle is a recipe for disaster. The huge torque required to move the mega wheel could snap High Roller's cables. The solution is to power the wheel from its rim. This reduces the load on the cables. But the wrong propulsion system can destroy a big wheel's reputation. In 1895, engineer Walter Bassett opens this 94-meter tall Ferris wheel in London. Bassett's engineers fix a pair of 300-meter long chains around the rims to turn the wheel. A pair of underground steam engines pull the chains. 2 5-ton weights keep them taut. In July 1895, a weight breaks loose. An 8-ton chain falls slack and jams between the rim and one of the carriages. The wheel comes to a grinding halt. Trapped passengers wait 7 hours for the chain to be repaired and for the wheel to start moving again. In Las Vegas, engineers deploy a rugged propulsion system to keep high roller turning big passenger numbers. 8 units fitted with 4 large truck tires, pinch shafts attached to both sides of the rim. A 95 kilowatt electric motor powers each tire unit to drive the wheel around. It's critical the system works flawlessly to cope with increased demand during this spring break weekend.
Reliability is key for this attraction. One of the critical elements in maintaining this reliability is the maintenance that has to take place every night, 365 days a year.
From 2 a.m. each morning, the wheel closes and High Roller's dedicated maintenance team gets busy. Senior mechanic David Pinkerton must ensure the tires and motors are in perfect condition.
When we're checking the tires, we're looking for cracks, we're looking for bubbles, we're looking for low tread, we're looking for low tire pressure. All right, Josh, let off a little bit. Looks good there, Josh.
David and his team must find faults during this downtime. Failing tires while the wheel is running could knock High Roller out of service and seriously dent its reputation.
So it's all done, all the tires are good? Yep, we're clear.
With the tires ready to roll, next the team checks the motors. If any of them fail, the big wheel has built-in redundancy to keep turning at its normal speed of 30 centimeters per second.
We run with all 8 drive units at one time. We could operate with 6 drive units. If we lose 2 more drive units after that, then we're in half speed.
High Roller's engineers also build in a backup generator to keep the motors running if the electricity switches off. But there's always the risk a freak event could cut both electric and diesel power and bring the big wheel to a grinding halt. In the unlikely event the High Roller loses all power, it can fall back on an ingenious failsafe. 2 independent diesel motors power a pair of 3.3 meter long hydraulic arms. The front arms grip the wheel's rim and push it around. At the same time, 2 back arms extend, grip the rim and pull the wheel. Repeating the sequence rotates the wheel smoothly. Using this system, workers can rescue all High Roller's passengers in just 2 hours.
This is the last chance that we have to get people down. We won't use this unless we lose power to everything.
David and his team must test the system to be sure it'll work in the worst-case scenario. The hydraulically powered arms spring into action. They grab the wheel and pull it round. The system works without a hitch. Saturday night of the long spring break weekend, the party is in full swing.
5 minutes left, guys, 5 minutes.
High Roller is going strong. 24 hours remain of the holiday weekend. To keep wowing the crowds, the wheel must deliver a spectacular experience every ride. What ingenious technologies help the capsule stay perfectly level at every point of High Roller's rotation? And how does the wheel keep thousands of passengers cool in the searing desert heat? (10 a.m. Sunday, the last day of the long spring break weekend. Eager tourists line up for Las Vegas's star attraction, the High Roller. Over the next 15 hours, it must fly thousands more people above the city's world-famous skyline. The temperature this morning is a balmy 25 degrees Celsius. Ensuring this wheel can survive Las Vegas's extreme climate is a huge challenge for High Roller's engineers. In spring, the mercury can top 34 degrees. If made from regular glass, temperatures this hot will turn the High Roller's 28 capsules into mini greenhouses, frying their occupants. So the wheel's designers build in the ultimate see-through barrier to beat the heat. A special coating reduces the penetration of the sun's energy into the capsules. Handmade double-paned glass stops heat radiation from passing into the interior. In a closed capsule, the air temperature is also critical.
All right, Josh, that's good. I'm gonna run up and grab the level.
Every night during High Roller's downtime, David's maintenance team test each capsule's air conditioning unit to make sure it pushes out air at a comfortable 23 degrees Celsius.
Air conditioning in Las Vegas, it's a necessary thing you have to have. You can't live without air conditioning in Las Vegas. The AC units, we change the filters and make sure they stay clean, because if the filters start getting clogged up, the airflow's not where it should be, and it'll make it get really hot in a cabin.
Batteries hooked up to each AC unit guarantee every capsule up to 6 hours of cool air if the mains power supply cuts out. Climate control ensures passengers enjoy a pleasant ride. Another challenge facing the wheel's engineers is how to create the sensation of floating serenely through the sky. It's critical the capsules stay perfectly level at every point of the High Roller's rotation. The cabins on early Ferris wheels hang from axles attached to the rim. These pivots rely on gravity to keep the cabins level. But this design makes for a rocky ride. Traditional cabins move freely about the axles that suspend them from the wheel's frame. This leaves the passengers inside vulnerable to feeling every bump caused by the wheel's turning mechanism, and puts the cabins at the mercy of strong winds. Both factors reduce passenger comfort. Worse still, for most of the ride, the structure of the wheel itself interrupts the view from the cabins. To solve these problems, High Roller's designers take gravity out of the equation. They use support struts called V-legs to fix each capsule to the outside of the rim. But doing this has the potential to jeopardize the passenger experience. Fixed capsules will turn upside down as the wheel revolves through 360 degrees. To solve the problem, engineers grip each capsule with an ingenious gear system. As the High Roller spins in one direction, the wheel's capsules must rotate in the opposite direction to stay level. To turn precisely the correct amount relative to the big wheel, engineers fit each capsule with a toothed 5.3-meter diameter ring. An attachment arm connects the ring to a cog. As the wheel rotates, the cog's teeth turn the capsule's ring. This makes sure every capsule stays level, no matter where it is on the wheel. The system means engineers can mount the capsules on the wheel's exterior. This guarantees passengers experience spectacular, uninterrupted views of Las Vegas.
One of the best ways to find out if you're actually moving or turning is to watch the relationship to the V-leg. Here the V-leg is holding us by the side. When we first loaded, it was supporting us from the top, and when we were at the top of the ride, we were actually sitting on top of the V-leg. So as you're making your trip around, not only is the cabin doing a 360-degree turn, the wheel and the rim itself is doing a 360-degree turn.
Every year, High Roller spins over 1 million visitors above Sin City. Inside its perfectly level, temperature-controlled capsules. 1 p.m. Sunday. The long spring break weekend is almost finished. Over the past 60 hours, the 2,200-ton wheel has completed over 100 full rotations. With a late passenger surge expected this evening, it can't afford to break down now. What near frictionless engineering keeps this mega wheel turning? And what stops damaging desert sand from bringing it to a grinding halt? Sunday afternoon in Las Vegas. The spring break long weekend is almost over. In the last 72 hours, the mighty High Roller wheel has spun thousands of tourists over Sin City. Rotating around its 30-meter-long spindle continuously for 16 hours is an epic engineering feat for an observation wheel this large. The rim, capsules, cables and hub weigh 2,200 tons, equivalent to 15 blue whales. This much weight turning on the spindle creates massive friction. Metal grinding on metal risks catastrophic mechanical breakdown. It's critical the moving metal parts slip past each other with as little friction as possible. In early 2013, engineers install a pair of 2.3-meter diameter roller bearings. Each one locks 60 free-moving roller elements within 2 steel rings. They seal the 9-ton bearings inside the 5-meter tall steel cable anchors. A giant crane lifts each one 80 meters off the ground to their final positions on the support legs. The installation of the bearings, hub, and spindle takes 2 months. The High Roller's desert location creates a major problem for machines with big moving parts. Strong winds blow sand and dust across Las Vegas. If these abrasive particles build up inside the roller bearings, they will damage the precisely engineered metal components, and the wheel could come to a grinding halt. Mechanic Brian Arellanos is responsible for keeping the mighty bearings dirt-free. During crucial maintenance shifts, Brian and a co-worker ascend 270 ladder steps into the very heart of the wheel.
Right now we're actually inside of the hub of the High Roller. This is the static spindle that stays still. On the other side of this seal is the bearing itself that's connected to the hub. And if the wheel were to be moving right now, we'd be rotating with the hub itself.
High Roller's secret to beating the grit is grease. Lots of it. Pumps inject 1 kilogram of lubrication grease every day into the sealed housing containing the roller bearings. This constant flow of grease flushes out any particles that could grind the metal components. If the oozing grease contains foreign particles, Brian knows the roller bearing seal is broken and needs fixing.
All around us is the bearing, and this system right here is where our grease pump pumps the grease into, and this is where the excess grease gets flushed out.
The team regularly sends samples of grease to a laboratory for inspection under the microscope. But Brian is the first line of defense.
We do check it every week, and if we could see something with our naked eye, we know there's an issue with the high roller. We don't see any kind of foreign material in there, we don't see any air pockets, and overall it looks pretty good.
"5 p.m. Sunday. More eager riders stream aboard High Roller. The mighty wheel is on its final leg of this epic spring break long weekend. By the end of the day, this ultimate mega wheel has completed nearly 130 rotations and flown thousands of passengers over Las Vegas. Mission accomplished.
We had a very successful weekend thanks to our team. Because we were fortunate enough to create a Las Vegas icon, now the pressure is on us to make sure we maintain it and continue to operate for the next 50+ years.
High Roller soars higher, works harder, and carries more passengers than any other wheel in North America. Built into its huge frame are a series of engineering marvels that make it the pinnacle of observation wheel design. Innovative building techniques make construction possible within a crowded landscape. The unique support frame anchors the mighty structure to a tiny footprint. The one-of-a-kind single-rim design stays rigid in the strong desert winds. A diesel-powered hydraulic arm keeps the wheel turning if the electricity fails. Precisely geared, temperature-controlled capsules stay perfectly level around every rotation. This is a wheel that is big, gives its passengers an unrivaled field of view, and is now a landmark in one of the United States' most recognizable cities. The High Roller, built to be the ultimate mega wheel.